Welcome back to my class. The topic that we will be discussing today is typecasting. So when we talk about typecasting, the first thing that we will talk about are the various types of typecasting. Now typecasting can be broadly classified into two groups, that is implicit typecasting and explicit typecasting. Now when we talk about implicit typecasting, this is something that is done by the compiler automatically. It takes place when an expression has got more than one data type in it. In such cases, type conversion or type promotion takes place. That means if we have got an expression comprising of different data types, the resulting expression is going to be of the data type which takes highest amount of space. For example, char gets converted into shortint may get converted into int may get converted into unsigned int, float may get converted into double, and so on and so forth. This is a small example of how implicit typecasting works. See, here we have got the alphabet A being stored in the variable called alphabet. When we try to print this value as a character, we get to see the variable as the value A. We get to see that the variable has got the value A. Now we are considering another variable called number, which is of type integer, and we are assigning the value of the variable alphabet into number. Now when we try to print the value number, we can see that if you use %c, we get to see A. If we use %d, we get to see 65. Let's execute it and see whether it actually happens or not. Hash include stdio.h int main. Inside the main, first thing that I'll do here is I need the variable number of type integer, and I need a variable alphabet, let's call it alpha, of type character. Next, what we will do is we will store the value A in the variable alphabet. So let's say alpha is equals to character small a. Now we will just print the value of alpha. So printf \n alpha is, or alphabet is %c, comma alpha. Enter. Now I will be doing something that is called implicit typecasting. I will try to store the variable alpha into the variable number. Now let me print number as both integer as well as character. Here what happens, this first %d gets associated with the first number, and this %c gets associated with this number. Finally, semicolon, and then return 0. Let's save it. So escape :wq gcc implicit.c, enter. Let me give it a nice name, /implicit. So as you can see here, alphabet is holding the value A as in character. Number as integer is holding the ASCII value of A, which is 97, and the number as a character, if we try to display, we get the character A again. So this means that the number, even though it's an integer, it's getting automatically typecasted into or a character is automatically getting typecasted into an integer. So the problem with implicit typecasting is that it can lose information when signs are involved, and also when something like a data type comprising of higher size is implicitly typecasted into a data type of smaller size, overflow can occur. So signs can be lost if we try to convert a signed integer implicitly into an unsigned one, and then there can be overflow. For example, let's modify the example that we had taken. So let's open up implicit.c again, and let's make some further changes in this particular file. So what we will do here is after this number's value has been displayed, let's consider now there is another variable of type floating point. So let's call it float pi equals to 3.14. Now the next thing that we will be doing is we will be typecasting a floating point number into an integer. So see what happened here. A character is promoted to an integer. Now we will be trying it the other way. That means here, instead of storing a character inside an integer, now we will try to store a floating point value in an integer. So now let's make number is equals to pi. Now let us display the value of number. So printf \n number as integer is %t and number as float is %f, comma number, comma number, skip colon double q, saved. Now let's compile it again. Okay, so it's a warning that we are getting. Why are we getting that warning? The warning we are getting is because here we have used %f and here we have used number. Now type of number is basically an integer, and this one is corresponding to the floating point data type. However, here it's a warning and not an error, so we will ignore the warning for the time being and we will execute the code. So let's run the code, see what we are getting here. We had initialized the variable pi as 3.14 and we have tried to store this number into an integer. So you can see as an integer the value of number is 3. Everything that was there after the decimal point in pi, that has simply been chopped off. So all we have is 3 here. You can ignore what we get as floating point number because of this warning it is giving us a 0.00. Okay, so therefore we can see that loss of information happens when we try to implicitly typecast a data type of higher size into a variable of smaller size. So this example just establishes that information. So here, this is the case that I showed you, the simple example. Here we have got a double value 4150.12 and we are trying to store it in a variable of type number. So when we try to display the number, the value of the variable number, we get 4150 and 0.12 gets chopped off, just like 0.14 in our example. When we talk about explicit typecasting, this is something more of user defined, and here we can typecast a particular expression into a particular data type forcefully by using the syntax something like this. So type then expression. So here suppose we have got the number 35 and we want to typecast it into a value of double type. So here we get double. So we write double like this. It's only then that we can display it as a double value. Let's try this example. So here you can see the previous example what we did. When we tried to print an integer as a floating point number, we got 0.0000 over here. Now this is where explicit typecasting is required. So I'll just open up the code once again, and now what I'll do here is something like this. So what will I do here is I will just simply consider another integer. I'll just remove this floating point number from here and I'll declare just float pi, and let me consider another integer, say integer I, which is equals to say 50, and then I'll explicitly typecast the value of I into the floating point variable pi. So what I'll write here is pi equals to float of I, and then let me display pi. Printf pi is %f. I need to change this into %f because pi is a floating point number, and then here I'll just display pi. Now let me just clear the screen. So GCC, I'll just /implicit So you can see pi is getting converted into a floating point number where this 6 zeros after the decimal point gets appended to 50 because it has been typecasted. Now instead of going for this implicit typecasting, instead of doing this kind of a thing, if I had written, so let me insert, if I had written just pi is equals to I, let's see what happens. Pi equal to I. Same thing. So the basic idea is when you are forcefully converting a particular data type into another, for that we need this typecasting, explicit typecasting like this. Okay. So as you can see, if we give the typecasting like this, or if we go for explicit typecasting like this, or if we go for an implicit typecasting like this, the output doesn't make much of a difference. So where exactly is this explicit typecasting actually required? Where do we actually need to do this change? So recall the program that we did for conversion of a temperature from centigrade to Fahrenheit. Now in such a case, in that program, the idea was that C by 5 equals to F minus 32 by 9. So when we tried to take a temperature as centigrade and wanted to convert it Fahrenheit, how did we do that? So let me go back. Let me create the temperature.c file again. So gcc temp.c minus o, then temp, enter. Now /temp. What happens? Enters the temperature in degrees centigrade. So the temperature we are trying to enter is, say for example, 100 degrees centigrade. What happens? What is the corresponding temperature to 100 degrees centigrade? Now what we are getting is 132. And let's run it again. What do we get for 0 degrees centigrade? We are getting 32. So for 0 degrees, we are getting 32 degrees. Now let us check whether this is correct or not. When you are trying to convert 100 degrees into Fahrenheit, so 100 by 5 should be equal to F minus 32 by 9. So when you cancel out 100 by 5, you get 20. 20 into 9 gives you 180. 180 plus 32 should give you 212 in degree Fahrenheit. But instead, what are we getting? We are getting 132. Also, when we are talking about 0 degrees, so 0 by 5 should give us 0, into 9 should give us 0, so plus 32 should give us 32 degrees centigrade. That part we are getting right, but we are not getting this correctly. What must be the reason for this? See, the reason for this here is that when you are trying to perform this operation over here, that is 9 by 5, we are actually performing an integer division. So integer division means what? Automatically the value 9 divided by 5 gives you 1 instead of 1.8. That is what is making the difference out here. If C is 0, you multiply this, the entire thing, whatever you are getting to 0, so this entire part becomes 0. But in case C is equal to 100, this is where the difference is happening. So for this, what we need to do, one way to modify this or one way to change this is doing something like this. This is going to solve that problem. So let me just compile it and show you. So entering temperature in C, if I enter 100 degrees centigrade, now you can see I'm getting 212. Another way to solve this problem is where we can go for explicit typecasting. Here I'm going to convert 9 into a floating point number explicitly. So what is happening here is float of 9, this is going to explicitly convert the 9 here into a floating point number, that is 9.0000. When I divide that by 5, automatically this is going to be a floating point division. When I multiply that by C, again multiplying into a floating point number, so it's absolutely fine, and that should usually work. So let me just save it and recompile it. So if I enter the temperature in 100 degrees centigrade, you can see the temperature I'm getting in Fahrenheit is 212. So these are the explicit cases or explicit requirements where explicit typecasting has to be implemented. So the generalized idea is that whenever we try to typecast a higher order data type into a lower order data type, it involves some amount of data loss. But if we try to typecast a lower order data type into a higher order data type, there is no data loss. That's all about typecasting.